Alrighty, now that we have this concept of Occam's razor and we can apply it to science and math and all that, we can answer a whole group of seemingly difficult questions that just actually all answer themselves. It's like a domino effect. People ask me, well, how did you know this stuff? Well, the answer is I already knew it. They say, well, how are you so sure? And it's like, because it's obvious. But it's not obvious to people. I just figure it's obvious. People say, well, how are you going to explain this? I'm like, I don't have to. It's self-explanatory. Well, we start out with these questions. What is the genetic code? What is life? What is the universe? What is math? But then we can add these questions. What is the origin? Is life universal? What is the function of life? How is order formed from chaos? I mean, these are the kind of things that a good scientist trained in modern times should be contemplating and should already have answers to. Okay, I guess they don't. I guess that's not what's going on in science. But I think for me, I already knew geology, which includes crystals and evolution and all that stuff. I already knew math because I was born with it. I already knew the life sciences because I had to become a doctor, and I already knew I taught myself computers, and I think the computers are the most interesting thing there is. And so one of the questions you get is, how do you form order from chaos? This is the same question as how do you make a machine think? So the question is, how do you take a bunch of random shit and then turn it into this highly determined linear, you show it can play chess, it can recognize an image, it can write a book. I mean, how does that happen? Well, whatever it is that computer's doing, that must be what the universe is doing. So the question is, when do you have intelligence? And the answer is obviously whenever you have a sufficiently complex network of logic, the opportunity for intelligence is there. And anytime that this intelligence becomes sufficiently complex, then you have the opportunity for consciousness. Well, this kind of idea has been around for hundreds of years. This is what Schrodinger was talking about. So, you have to look at these simple computer models and say, well, that's it. Well, for me, it was, these fractal von Neumann, cellular automata. You can watch it happen. You can watch chaos turn into order real quickly. So, the only thing I was missing in terms of my thought process was, how do you get a sufficiently complex network of logic that is the basis of life? Well, if you're going to go with this, you're never going to see it. But as soon as you know it's this, which I did in a heartbeat, then all these other questions answer themselves. So, we can go down the line and answer some of these things. I find it interesting. I think, to me, the most interesting question is, what is the origin of life? I'm just shocked that that's not more interesting to people. This Karen Smith guy, I think he's the thought leader. I think that Schrodinger set the pace when he asked, what is life? If you don't know what life is, if you can't define what life is, if you can't define what something is, you can't know the origin of it. Okay? So that's why Shannon is important, because he tells you what information is. Well, life is molecular information. So what's the origin of molecular information? I think that Karen Smith, he built his arguments from inorganic to organic, and then he climbs up the ladder, and he gives a very convincing argument for consciousness, which I mostly agree with. But I think his explanation of consciousness is a better explanation of the origin of life than his explanation of the origin of life. I think the missing piece was this information theory. He didn't know, he never even uses the word the genetic code in his explanation. Well, the genetic code is the origin of life. Without this code, there's no life. So if you know the origin of the genetic code, then you know the origin of life. Well, in order to know the origin of the genetic code, you got to know what it is. Well, if you think it's this, then you're going to struggle to figure out its origin. If you know it's this, which I did, boom, the origin's obvious. Now all of the other questions answer themselves. Okay, and now today in modern times, this woman is now apparently the leader in the uh, question of the origin of life. The title of the book is appropriate, Life as No One Knows It. That's exactly right. No one knows it. If you don't know that this is the genetic code, then you don't know what life is. So, remarkably, she doesn't even use the word code in the book or the genetic code. None of these people do. It's because they don't like the definition of the genetic code because it doesn't work. I mean, if it's not math, then you can't understand the origin for it. Once you know it's math, now all of a sudden the origin's clear. So, if you look at the origin of life, I mean, the first thing you got to realize is that we've got these different mathematics. Well, what is a math? Math is an equation. This is equation for gravity, the equation for quantum mechanics. What's the equation for life? Another way to say it is, what is the function? What's the function of life? Well, in my opinion, the function of life is to place atoms in space through time. That's the function. Okay? Is it universal? Yes, it's universal. This is a universal function. We can think of it in terms of a law, a single law. You start with a gas and then you go to a liquid and you go to a solid. The law is it's going to seek an entropy minimum as it forms. But then it's also going to try and create, life is going to create the most entropy that it can. So its function is to create molecular information. Like Schrodinger said, it's going to feed on negative entropy. Okay, so what is the genetic code? The genetic code is math. What is life? Life is the physical manifestation of this code. The code is literally plotting atoms in space through time. It's literally building a crystal. Literally is math. It literally is a machine. Okay, what's the origin of it? Well, what's the origin of gravity? Well, the origin of gravity, I mean, it's a fundamental law of nature. It's the function. What's the function of gravity? It's to bring atoms together. What's the function of quantum mechanics? It's to build atoms. So you got to have a function to build the atoms. You got to have a function to bring them together, and you got to have a function to arrange them in this complex thing that we call life. Well, life must be a subset of all atoms. I mean, all possible atoms and all possible configurations. Life is a subset of that. So when you look at these crystals, I mean, they don't even have a mathematic for crystals. They can't use their math to explain quasi-crystals. Well, if you can't use your math to explain quasi-crystals, then you're not going to be able to use your math to explain life. Okay? Well, the reason you can't do it is because it's overdetermined. You're trying to do it with too few axes. You don't have enough dimensions of space to define your crystals. Well, if that's true for quasi-crystals and snowflakes and stuff like that, then it's going to be true for life too. You're going to have to find a new math. Well, how about this one? This is the superposition of all crystals. That's a pretty good math. Anyway, well, then you start saying, well, what's the function of life? Well, now you're going to get into evolution. In evolution, there's two kinds of things. There's an analog and there's a homolog. Well, an analog has a shared function, and a homolog has a shared origin. So an analog would be a site. Site is so important that all these different life forms invent different ways to make an eyeball. That's an analog. Homolog is, okay, like my arm is a limb, and so is a bat wing. Well, those two structures have a common origin in mammals, but they have, and a whale has a flipper. Those are all homolog structures. They have a common origin, but now they have different functions. Well, the question is life itself an analog or a homolog? And whatever your answer to that is, that's got to be your answer to the genetic code. The genetic code, does it have a single function across all life? The answer is yes. It's a universal function. The universal function is to place atoms in space through time. That's what life is. Life itself is an analog. So when you look across all life, the first question is, what's it doing? It's generating molecular information. What is molecular information? It's spatial information. So trying to understand life without the concept of spatial information is like trying to understand an eyeball without the concept of sight. And if you don't know that eyeballs are used to see, then you won't understand why all these structures have evolved. If you don't know that life's function is to make spatial information, then you won't realize why the genetic code is universal. I mean, the code itself is universal, but the molecules are changeable. Okay, we're going to see different molecules in different circumstances. You know, when we go and find life on another planet, which is inevitable, it'll be the same code, but there'll be different molecules. It'll be doing the same function. Okay, it's the genetic code is universal. It's a fundamental property. It's a mathematical property of the universe. Okay, that's why all these codon tables are so damn. It's not because they're homologs. That's impossible. And if you started out with a cell that had this genetic code, there's no way that first cell would be anywhere close to perfect. And so it would spread out. We would see lots of different codes, but we don't. We see one code. That means it's an analog. That means it's coming to a point at a function. Okay, so what's the origin of life? Well, it's the origin of the universe. It's embedded in the universe. What's the origin of life on Earth? Well, it's the origin of the Earth. Well, what is it? Well, it's a crystal. It's a precipitated out of seawater. So how are we going to identify at what point in time do we identify? They've got these magical properties for these molecules. So they figure, hell, these things are so magical that all we got to do is get them to one place at one time. Well, that's impossible. None of these molecules could have existed at the origin of life. They all had to be invented. They all had to be learned. The machine had to learn these molecules because the machine is learning the optimum configuration of these molecules. Okay, so you're not going to find a set of molecules at a particular time on the Earth. So now you got to broaden your scope. What you're going to find is, I mean, if you go to the ocean now and you take a drop of seawater, you see life everywhere in every drop. That's true. As we go back in time, it's going to be true. It's going to be true. But it's like pH. It's like a quality of the seawater. Okay, life's going to be getting stronger. Okay, that's where the ideas in this book are relevant, because she's talking about complexity. That when we go and find life at a different planet, what we'll be able to do is measure the complexity of the molecules. Well, that's true. But those molecules will have to be a part of a code. They will have to be a part of a mathematics. They'll have to be a part of a function. And the function is to increase the complexity of the molecules. So you could take a drop of seawater going back and you could measure the amount of complexity in the seawater. It's not one particular location. It's the entire sea, the whole ocean. That's your set, the set of the ocean molecules operating within this dynamic field of water molecules. Okay, so so all these questions, it's like a domino effect. And once you find the one missing piece, then they all answer themselves. I mean, what is the origin? Is it universal? What is the function? How is order formed from chaos? I mean, you've got these chaotic atoms. They're self-organizing into this amazingly non-chaotic machine, which is a miraculous crystal ball of molecular behavior. So, this isn't a set of 8 questions. This is one question. There's only one missing piece. We should all already know all this stuff. And then the missing piece is this. Well, if you know that, then boom, boom, boom. They all just fall like dominoes. It's, oh, okay. Well, I thought it was hard, but it's not. It's easy. Okay, well, I shouldn't have to explain any of this to anybody. You should already know this. This is just simple logic. It's just remedial math. I mean, what do you think math is? Do you honestly think this is math? This isn't math. This is crap. Okay. This is not the mathematics of life. This is not the function of life. This is not the code of life. Okay. This is a recipe. This is an ad hoc quilt. that was put together by people who don't know anything about math or information science or evolution. But they just said, we're not going to let it evolve. Well, how are you going to do that? Well, there's a functional imperative. I mean, they're just making it up. So I can't believe that that I have to explain this. I can't believe people get so mad about it. But they do. They get really mad. And they start calling you names. It's like, look, dude, just back off. You don't like my paradigm, make your own. But we can both agree that this other paradigm's got to go because it's not working. We can't just keep excusing all these epicycles. There's too many epicycles. Okay? We can't just keep making this up. This is useless. It's worse than useless. Okay? So we can take this paradigm. Maybe it's right, maybe it's wrong. It works for me. It works for me because it's the simplest possible paradigm. I already knew it worked because I had this damn machine and that operated it. Well, that's all I need to know. It's a machine language. It's mathematical. Life's mathematical. It's not ad hoc. There's a logical explanation, so we can then mathematically extrapolate backwards to the beginning. Well, what's life? Life is a fundamental property of the universe. Well, there you have it. There's your origin. You can actually hold it in your hand. Hey, look, the origin of life. Look at that. It's not very heavy. Look at that. Oh my gosh. Now we can see how life is animated. It's crazy. It's cool. And now we can map it out. And then we can start seeing, oh, look how this operates like a search algorithm. Well, why would it do that? Well, because it's got a search. This is the most powerful search algorithm I could ever imagine. I mean, it's just like off the hook, and life is off the hook. It's aggressively searching. What's it aggressively searching? It's aggressively searching the language of life. It's trying to find pieces. It's inventing pieces, putting pieces together logically so that those pieces can build more complex pieces. It's a self-learning algorithm. It's turning chaos into perfect order. The linearity of it is the perfect order that it generates. It doesn't start with perfect order. It generates perfect order, okay? So get your cause and effect in the right order, and then you can start talking about this stuff in some kind of logical way. So anyway, it's hard to believe that it's this hard to explain, but it is, because people are so infected. It's like a reality distortion field. This distorts their reality, and then they're like a 3-year-old, like a drunken 3-year-old. It's like, whoa, wake up! We're talking about math here. They can't do it. It pisses them off. I don't know. I don't know what to tell you. This is the best I can do. This is as simple as I can make it. All righty. Well, now what do you want to talk about?